Hey everyone, so this is a quick tutorial on how to find slant asymptotes. Now, slant asymptotes are also called oblique asymptotes in rational functions. They are slanted. They are not a vertical line. They are not a horizontal line. They are slanted. They have a slope, an equation with a line that has a slope, versus a vertical asymptote, horizontal asymptote is a line with a slope now. Let's check out an example of a rational function that has a slant asymptote, and then we're going to go backwards and try to figure out how we are going to find the equation of that line. So if you check out this green function here, this is the equation that gives me this graph. You can see quickly that I have a vertical asymptote at -3. So I have a vertical asymptote right here. And we can also get that directly from the function, right? Set that equal to 0, you'd say x equals -3 is your vertical asymptote. So slant asymptotes are a little bit trickier to calculate, but we can visualize. And I want us to kind of put in a rough sketch here of where we think this vertical asymptote is, and then we're going to find it exactly. So it has to be this curve, whoops, this line that goes along the curves of the graph, but doesn't touch. So somewhere around there, and that should be a dotted line to represent a slant asymptote. Let's figure out how we are supposed to calculate the equation, right? We're looking for an equation, y equals something is going to represent that slant asymptote. So how to find slant or oblique asymptotes? The only time slant asymptotes happen is if the degree of the numerator is 1 degree greater than the denominator. Then there's a slant or oblique asymptote. So notice the numerator degree is 2, the denominator degree is 1. That's why I have a slant asymptote. If you remembered before, these do not have slant asymptotes. Look at the degree of the numerator. Degree of the numerator has to be 1 greater than the denominator. For example, it could also be like 5x to the 4th plus 3x squared minus 7 over -2x cubed minus 1. If I looked at this function right away, boom, we need to know there's a slant asymptote because the numerator degree is 1 greater than the denominator degree. So once we check to see, oh, the numerator degree is 1 larger than the denominator degree, we have to use synthetic division to divide the numerator by the denominator. And then the quotient, it's really important that we know it's the quotient, not the remainder, is the linear equation of the slant asymptote. So let's go ahead and we're going to test that out. So I look at this as the exact equation that we have already graphed. Numerator degree is 1 larger than the denominator degree. So we're going to go ahead and do synthetic division. When we do synthetic division, remember we have x plus 3. If I set that equal to 0, what we are going to put in the front of this synthetic division bar is a -3. We've already learned how to do synthetic division, so I'm not really going to walk through this precisely. So our a value in the front of our synthetic division is a -3. We're going to fill in the middle part of our synthetic division with x squared minus 4. Our leading coefficient is 1. We do need a 0 placeholder because we're missing the x term, and then we've got -4. Synthetic division, we bring down, we multiply, and then we add straight down. Multiply, add straight down. So once we're done, we have to remember this as our remainder, here's our constant, and here's our x. And this is going to be our quotient, right? We know our quotient is right here. We're forgetting about the remainder, so that means our answer to our slant asymptote is y equals x minus 3. Comes directly from our quotient right there. And so that's our answer, y equals x minus 3. So let's just check, does that make sense? Y equals x minus 3. So let's go ahead and graph that line. If I have my y-intercept is -3, 1, 2, 3. Wow, didn't mean to do that. And then let's go ahead and plot this point. It's just the slope is 1. So look how close the line is getting, the green curve is getting to our vertical asymptote. I'm going to go down 1 over 1. We're not really going to be looking at my gray line. My gray line is just my estimate, but you could see those green dots. And I can actually remove my estimate. You can see those green dots. That's where the green curve is getting really, really close to that slant asymptote, but it's never going to touch. Okay, those are your steps on how to find a slant asymptote. Great job, guys.